Hello, this is Sean Murphy, and this presentation's on the DL1400 Boolean Input Data Logger. Boolean Input Data Logger is actually both a temperature and Boolean Input Data Logger, depending on the order configuration. The specific one that we're going to look at today is the Boolean Contact version, and that actually looks a little bit different than its um, other configuration of the DL1400. It says contact logger on it, and it has numbered inputs on it. The temperature version that is going to, of course, have uh, temperature data logger on it, and it'll have thermistor sensors. So, what is a Boolean input data logger? It's a data logger that records the state of a two-state on-off contact output device. So it's reading the output from an external device. The data logger pulses a 1-volt signal into the contact device. The data logger detects either a 1-volt or 0-volt signal from the contact device corresponding to its state. If 1 volt is detected, the contact is closed. If 0 volts is detected, the contact is open. Basically, it's open or closed circuit. Um, and the data logger records a 1-bit Boolean, which is either a 1 or a 0, corresponding to the contact state. So essentially, the data logger is taking the voltage signal that's received and turning it into an on-off signal, a 1-0 in the software. So when you get one on the left-hand side over here, you have the contact and the data logger, and a very simple schematic on how they're connected. The data logger sends a 1-volt signal out and gets a 0-volt signal back when the contact is open. And the Boolean signal received by viewLinc and recorded on the data logger is 0. And when the contact is closed, which is the graphic on the right, 1-volt signal out gets 1 volt back. Because the contact is closed, it's a closed circuit, you're able to read that 1 volt that you pulsed out. And the Boolean status is 1. So what are the applications for a Boolean input data logger? Well, there's a couple of them. And you see they're actually very common with monitoring because it's the most simple output that you can get from an instrument, which is an on-off state, typically linked to an alarm output. You see these on skids, comet alarms, and freezers. You see these as being the outputs from water leak detectors, pressure switches, switchover valves. Everywhere in industry, there's an on-off alarm output. Um, and you also see it for door switch monitoring or reed switches. These are used for monitoring the state of a door on a freezer or your typical burglar alarms at doors and windows. Um, Another application that's very common with Booleans is power monitoring using dry contact relays. In other words, you have a power circuit, 110 volts, 500 volts, whatever it is, and you have a relay in between that senses the power going through it on one side. On the other side of the dry contact relay, you have this on-off switch that's tied to the main power line. So when the device is powered up, it energizes the circuit and changes the status of the relay, and you can monitor that. And basically anything where you have a two-state on-off signal output from a switcher or relay. The kind of connected devices you're going to see with Booleans is going to be electromechanical relays. I'll go into some detail on what those are. Semiconductor relays, reed switches, and any electrical contact as long as it doesn't have power. Now, from the viewLinc monitoring system standpoint, which is the endpoint for the Boolean data logger when it's connected through a network adapter and integrated with the viewLinc monitoring system, the data logger itself only has two values. It's a Boolean input, Boolean meaning 1 or 0, um, and the readings that you're going to see in viewLinc are going to be one of two states. It's either going to be 0 bool or 1 bool. And 0 bool is typically associated with being a normal condition because it's lower on the graph. And the alarm condition is typically 1 bool. So normal is 0 and alarm conditions is 1. So when you're configuring this in viewLinc, you're typically going to only set one threshold for this data logger with a value of 1. So essentially, anytime the alarm trips, it can trip the threshold. Now, I'm going to go into the two basic ways of being able to configure a dry contact relay. One is to be monitoring a circuit that is normally open. In other words, the contacts that you're connecting to under normal conditions is an open circuit. The first of them, and probably the most popular that you can see everywhere, is the electromechanical dry contact relay. This is an electromagnetic device where, if you take a look at the picture from the Grainger catalog there, that's a typical dry contact relay. You can see through the clear glass there that it has a electromagnetic coil that is directly tied to whatever sensing electronics exist inside the device it's connected to. And when that coil is activated, in other words, there's energy going through it, it turns into a magnet. And when it's magnetized, it of course attracts ferrous metals and any kind of materials that are subject to the pull of a magnet. So inside that relay, you're going to have three little wires that are in there, and each one of those wires that hang down are going to be connected to different terminals on the relay. You'll see them labeled on the outside as being no, COM, and NC. No means normally open. COM is the common terminal, and the NC is normally closed. Now, under a normal state of a relay here, the normally closed contact is in direct connection with the common terminal. So if you were to connect a circuit up to the COM and the NC, the current would flow through it, and the power would be on. And the opposite is true between the COM and the normally open contact, because that's got a break in the circuit. So during the normal state with a normally open circuit, you're going to have the state that you see here, where the NC and the COM are connected and the NO and the COM are not. In a alarm state, this is when the alarm electronics inside whatever piece of hardware that this electromechanical relay is installed in goes into alarm. It's going to energize the electromagnet. And when it does, it's going to move the little piece of metal in there that's connected to the COM and flip it from touching the NC contact to the NO contact. So the normally open contact is now closed, and the normally closed contact is now open. So it basically goes from being on to off. And we're specifically looking right now for the normally open state, which is the normally open and COM terminals on here. We'll get into the condition where we have the normally closed contacts on here being used later on in the presentation. So this is another diagram that kind of shows what's going on, but I'm going to focus more on the data logger and what the data logger is doing in these circuits. So in a normally open configuration, you have, these are the same three terminals that were in that graphic from before, where the COM has a switch that goes between the normally closed and normally open contact inside the relay. And under normal conditions with no magnetic pull towards the normally closed contact, the circuit is closed between the normally closed contact and the common. Now, when you connect a data logger to it, the data logger is going to connect between the normally open and the common. When you pulse 1 volt out, you get nothing back. And that's because it's an open circuit between the NO and the common. So that's under normal conditions. Now you have alarm state where you're energizing the electromagnet, and now the switch is attracted and connected between the COM and the normally open contact. Now the case with the connected data logger, well, 1 volt out gives you 1 volt back. So you get 1 volt detected, and that's a Boolean of 1. Now there's another type of relay that's out there. This is a semiconductor or solid state relay. There's a couple of different types of chips that are inside of here, MOSFET, CMOS, but they all do basically the same thing. You connect the data logger to one of 2 terminals, and a lot of times these are going to be polarized. So you need to understand a little bit more about where the positive terminal is on the relay itself. If you get it backwards, there's actually polarity to the contact logger, and it simply won't work at all. So you need to be conscious of that, and I'll get into that when I show you the way that the terminals work on this specific data logger. So under these conditions, when you send 1 volt out, it's an open circuit, so you get a Boolean of 0 coming back at 0 volts. And in the alarm state, the contacts are closed, and you get 1 volt out, 1 volt back, and it's a Boolean of 1. And as I said, the polarity matters. And one note on here is some things will say that they have an alarm output, but they don't actually have a relay in the circuit. I've seen it many times where they put half the electronics in there. They'll have the logic chip inside the motherboard that has a alarm output, but these are not connected to a real isolated relay where it's isolated from the electronics, and you have a truly separate circuit that's independent of the device that turns on and off. You have to read the schematics closely when you're working with anything that doesn't have a real relay on it. If they don't offer power specifications for the outputs, in other words, they're not telling you how many volts can go across the relay, or God forbid it says it has 24 volts coming out of it, you want to avoid using them, especially if it says anything about its powered outputs. In other words, it's actually giving you a 1 volt output or a 24 volt, 12 volt output to drive an external device like a light. You don't want to connect that to a Boolean data logger. It's not a Boolean signal. It's not a dry contact. It's a live power output to power an external device. So here's a warning, which is do not connect powered outputs to a DL1400 data logger. This is because the signal power comes from the internal data logger battery. If you drive power into it, you're driving power into the battery, and you can actually, in the extreme case, cause a fire because you're throwing a lot of energy into the circuit and overloading the data logger. If you're uncertain at all regarding your connections to the DL1400 data logger, make sure to test the relay outputs or the outputs from your alarm system with a multimeter, both in the alarm condition state and the non-alarm condition state, the on-off. If you're detecting any voltage coming from it at all, it's a no-go. Do not attempt to connect it. Because it's going to mess with the data logger, especially since we're sending out a very low voltage test signal, and just don't go there. The wiring connections to the data logger are pretty simple. There's 4 different ports that are on the data logger itself, and each one of those ports have a little connector. All the channels are internally powered by the battery on the data logger. So The contact logger will actually function even when the network is down. The internal battery is powering the data logger, and these are actually designed really to be standalone data loggers, so they don't need external power conditions. It'll actually use the little battery that's inside there, send out a brief pulse at 1 minute intervals, and record the status of the circuit. So no voltage, again, no voltage should be applied to the inputs on the data logger. And I'm going to go into a little bit more detail into the screw terminal block. Now this pulls out off from the actual data logger body, and this is where you terminate your wires from your dry contacts. So the top part there plugs into the logger socket, and you'll see there's two small screws in here. So you need a micro screwdriver to be able to clamp down and tighten the connections to the wires. Now, looking at the plug in this orientation, I'm showing you the polarization of the connector itself. There is a common. This has to do with the way the data logger is actually taking inputs. All the commons are connected inside the data logger. So that must be the negative terminal when you're connecting the device to a polarized relay. The contact input channel, which is the true input on the data logger, is the positive lead. And it's also going to be what you label as being the normally closed or normally open contact on a relay. Now it's actually, if you have a regular standard mechanical relay, it doesn't matter. There's no polarity. It doesn't matter whether the wire from the normally closed or normally open contact goes into the common or the input channel, because there's no polarization. There's no diode in there. There's nothing stopping electricity from going in the opposite direction. And now to get a little bit more involved with the way that pulses go from the data logger out to the inputs on the data logger. You can have, this is not uncommon, which is to have a relay block, maybe on a skid, that contains 4 relays. Or this could be a situation where you have a bunch of freezers and they all have common alarms and you want to capture them. So they're not necessarily on the same block. They can be completely different devices. The electronics work the same way. So essentially the logger sends out a 1-volt pulse. It goes to the commons and comes back on the normally open outputs on the relays, and it comes back as the pulse returned to the data logger. A data logger is going to detect whether there's 1 volt or 0 volts coming at each one of these inputs. So normal state is 0 Boolean, which is the open circuit. Alarm state is 1 Boolean, which is closed. Inside of viewLinc, you have the device configuration for the Boolean input logger. So you're going to, in the field there, you're going to give the device a description. You have a programmable sample interval on here. It can go as short as 10 seconds, and can go up to, at set intervals. Basically, it's not programmable. It's actually configurable inside of it. We always recommend 1 minute or longer for the sample interval to preserve the battery, because the battery is hardwired to the data logger, and it's not replaceable. So there's 4 input channels on the data logger. It'll show channel 5. That's really for a different type of data logger, so that's always going to be disabled. So depending on the number of contacts on here, you enable the number of channels that you're actually going to use. And for normally open relays, this is how you're going to set up the channel properties. You're going to give the channel a name. On here it says relay 1, but the way that you set up the value on here for what the Boolean state is under normal conditions. The 0 Boolean is going to be the value when the circuit is open. And 1 is going to be the value when the circuit is closed. So on the data logger configuration here in viewLinc, it's asking you what is the value when closed. So the value when closed for normally open contact is going to be 1. So when the contact is closed, it's an alarm state. And that's pretty much what all there is to the normally open contacts. Now, a lot of devices are going to go the other way, which is the circuit is normally closed when the relay source is in operation. As I mentioned before, you have the normally closed contacts. This is if you wire to those contacts. One of the things about it is you have to invert the Boolean on it, because if you don't invert the Boolean value on it, you're going to end up with the alarm being tripped all the time, and you'll end up with the alarm tripped all the time and turn off when it's actually an alarm state. So this is back to that original diagram of the electromechanical dry contact relay. And it's basically the same schematic, except for we're looking at the COM and the normally closed contacts. Now, this has the behavior where the normal state is a closed contact, and the alarm state is an open contact. So this needs to be configured as an inverted Boolean. And I'll get into how to do the inverted Boolean. So this again is the circuit to the data logger. When you pulse 1 volt in and 1 volt out between the normally closed contact and the COM, under normal conditions, you're going to get 1 volt back. But you want the Boolean to be inverted. You want the Boolean to be equal to 0, because that's your normal state. And you want to do the opposite with when it's an alarm state. You're going to get 1 volt out and get nothing back, but that's an alarm state. So you're going to want to have the Boolean equal to 1. So again, inverted Boolean. This is another device that's that uses the same kind of logic. This is a door contact. These are typically used for burglar alarms. We also sell these as being door kits that you could put on refrigerators. You put the magnet on the door, and you put the reed switch side of it on the base of the refrigerator. So when the door is closed, these two are in close contact. These basically are in a when the magnet is not near it, it has two little wires that are separated by a space. And this is basically an alarm condition, because it's not near the magnet, the door is open. So it's a contact that is an alarm when the circuit is open, and its normal condition is when the magnet is close by. So the magnet is far away. This is the alarm condition. You get a Boolean of 1. When the door is closed under normal conditions, the magnet is right up against the reed switch, and that forces the two leads inside there to touch each other and close the circuit. And the Boolean is 0. And that only happens when you invert the Boolean. And now back to the energy flow through the circuit. This is largely the same as the previous part of the presentation. The pulse comes from the data logger, goes through the commons, comes back. Instead of through the normally open contact, you're going to the normally closed contact on the relay. And of course, if it's a door switch, you just have two leads on it. There's no normally open contact. So it's just the con and NC, and they're with read switches, they're not polarized at all. So it doesn't matter which side of the lead goes to the input versus the comment on the data logger. And the pulse returns, and you get your 0 volts when it's closed, and a one a Boolean of 1 or 1 and 1 volt detected when the circuit is open. And that's an inverted Boolean. And now for the configuration of the data logger. Again, you're going to name the channel on it, but the value when closed is going to be different. So the normal state is 0 Boolean equals the value when the circuit is closed. And 1 bool is going to be the value when the circuit is open. So you got to make sure that you invert the Boolean here. So the value when closed is not 1, it's 0. And that's pretty much all there is to a Boolean input data logger. It's used to monitor on-off signals uh, from external devices, and the data logger itself is able to capture that at intervals typically of 1 minute. Thank you.